Before we begin our hike today, I'm at the Castlewood Dam, located in Castlewood Canyon, which is a state park that is located 30 miles south of Denver, near the town of Franktown, just south of Franktown, and just to the east of Castle Rock. This dam was constructed in 1890 along Cherry Creek, which carved out this canyon. So let's take a look at how Cherry Creek fits in with the drainage basins of eastern Colorado. This is the present geography of the eastern Colorado River basins. Cherry Creek actually starts in the highland area of Monument, labeled number 19, and flows north where it meets up with the South Platte River in Denver. So the dam stretched across the canyon and held the reservoir to the south. Looking at the blocks that this dam is constructed from, it is from the local area right here, a conglomerate called the Castle Rock Conglomerate. And in it you can see small pebbles and even large pebbles. During the night of August 3rd, 1933, after many days of rain, we're looking at the west side spillway here. The reservoir filled to the brim and overtopped it. The masonry apron that you're looking at here in the central part of the dam gave way, and erosion of the underlying Dawson Formation quickly ensued. With the support facing lost and the scouring that occurred below, it likely created a hole under the dam and caused the dam to collapse. The tender on duty was able to get the warning out, and an estimated 5,000 people fled the lowlands. Tragically, there were 2 fatalities. Our hike begins here at Lake Gulch Trailhead, trail number L. And the reason I chose this is because the other trails go down a side canyon, which is narrow and difficult to do. This trail goes along the old reservoir edge, and there's plenty of outcrops in place. Okay, so let's go. Here we are. This is the first outcrop that we see along our trail. It is in place. It does have a bit of erosion, but I think we can see through all that. The first major structural thing a geologist looks at when looking at a sedimentary rock is the bedding. The bedding is the main layering, and it tells you whether there was any tectonic activity that had occurred since this has been deposited. The bedding here is pretty flat. This outcrop from one of the adjacent parking lots probably shows the bedding a little bit better. So the next thing a geologist looks at is the composition. So you can see in here basically little pea gravel size. Oh, now there's some little bit larger cobbles. I'll call them cobbles. But pea gravel size grains with, again, a few larger cobbles. In one down here that's a little bit larger yet, a few around it. And so this is the top of the Castle Rock Conglomerate. There's a lot of cobbles right in here. These cobbles are fairly rounded, as you can see right here, like this one. Wow. So it indicates that they've traveled quite a distance, being rolled around in the streams. So let's go back to the beginning of this outcrop. The next thing a geologist looks for is the internal structure within the bed. So what I'm seeing here is what they call crossbedding. Let's talk sedimentary structures. Flowing water will cause the sand or gravel to form either straight crested or lunate crested ripples or bars. Sand will be forced up the gentle slope and cascade down the steeper slope. As it cascades down, it sorts itself and creates these crossbedding structures. It's these crossbedding structures that are preserved. It's rare that the surface bars or ripples get preserved long term. So we can see the crossbedding here go left to right. That means that the current was actually flowing left to right. And geographically, that means that the current was flowing south-southeast. Sometimes you can see bedding playing between the forceps there, like right here. And again, the large round cobbles. Crossbeds only preserve the bottom quarter to half the size of what the bar was. And considering that these are gravel bars and that those bars were fairly large, this must have been quite a powerful current. Continuing on down the path, we can see where the Castle Rock Reservoir once was. As we go farther down in the formation, we can see alternating zones of cobbles and boulders versus small pea gravel and coarse sands, as you can see right here. This indicates there was more than one depositional event. There are zones in this formation that have small boulders in it, like this one. This is highly unusual because we are a good 20 to 25 miles away from the nearest mountains. So these must have been much more powerful flooding events than what we have seen here in recent history. Most of these boulders and cobbles are metamorphic origin. This one is a banded gneiss. You might even be able to see the folds in it. There's a little bit of granite, but not much. This would be consistent with the debris coming from the mountains to the northwest of us. Oh, and look at this. This is an important find. This is a blue quartzite, and this quartzite outcrops in a very narrow band between El Dorado Canyon over to Coal Creek Canyon and a little bit into Golden Gate State Park. Oh, and here's another piece. This indicates that this debris has come from as far away as 50 miles from the northwest. Here is a map of the most likely drainage pattern that occurred back during those times. The flow and the flooding was from the northwest to the southeast. We also see desiccation cracks indicating dry periods. As we walk along, there are a number of places where this material pops up. These are large, irregularly shaped material from a very local formation called the Wall Mountain Tuff. The flow must have cut a canyon through this tuff, and these blocks probably fell off the canyon walls and thus are angular because they didn't roll that far. The tuff is a volcanic pyroclastic flow that was deposited throughout this area. Because it's volcanic, it can be dated and was dated at 36 million years ago. This indicates that these floods probably occurred around 35 million years ago. So there you have it. In summary, there once was a river channel that cut a canyon through pre-existing rock. This river flowed south and had tremendous floods. In an ironic twist of events, in 1890, a dam was constructed across the canyon that Cherry Creek had cut through. That dam was made from the debris of those 35 million year old floods. In 1933, that dam failed, resulting in a flood flowing in the opposite direction, northward, and flooding Denver. This is Michael Delvaux. Thanks for hiking with me.